Okay, welcome to this next video, guys. We're going to be talking today about summarizing data graphically. And the learning goal for this one is that you'll be able to construct stem and leaf plots and dot plots, and that you can describe the relationship between the median and mean in some data displays. Okay, now you'll be able to create a stem and leaf plot or dot plot to describe some data, analyze measures of center from a graph, and interpret the skewness, which is something different, of a data set we'll talk about a bit later. Okay, sometimes we want to ask the question, what does the data look like? Okay, now, if we had sort of a set of data that was surveying how many, let's say, how many stones that people found in their shoes when they took their shoes off, you might find it is maybe 2, 0, 1, 0, 0, 0, 56, 1, 5, 7, 11, 0, 201, etc. This goes on and on and on. And you think, well, what's the average of that going to be? I'm going to have to get the calculator out and really punch some numbers in to get an idea of what that data set looks like. Now, what we can do instead, because that can be quite annoying to have to do that, is that sometimes we want to make a display of that data because it's easier to communicate it to people who may not be familiar with the mathematical side of statistics. Okay, and so we might graph that, and so instead we'll end up with a nice little picture like this, and this axis might be number of stones, and this might be the number of people who had that many stones. And it might end up with this nice graph that showed, wow, heaps of people had lots of stones. Heaps of people had only like, 3 stones in it. But then, there was these weirdos out here whose shoes just seemed completely filled with stones, but there weren't very many of them. And so you say to yourself, okay, in here is probably going to find our average. Okay, our measures of center are going to be in about that area there, about 3, 4, 5 stones. Okay, so it's a lot easier to figure those things out when you're looking at it graphically than have to see all the numbers and try and process that quickly. Okay, right, so let's have a look at some of these different ways we can do that. So our first one we're going to have a look at is this thing called a dot plot. Now, a dot plot is a graph where each little individual piece of data is placed onto columns depending upon their value. Okay, and we're going to show you, I'm going to show you now how that sort of looks. So if I'm going to present the following data set on pet ownership as a dot plot. So let's pretend these are some data that we collected from a survey of how many pets do different people own. So you've got 2 pets, 5 pets, 8 pets, etc. Okay, the way we put that onto our dot plot is we've got 2 axes here, and so maybe this axis will be number of pets. Okay, and this axis would be the number of people who owned that number of pets. Okay, and then we sort of go through, so this is going to be 0, 1, 2, 3, 4, 5, 6, 7, and 8, because it goes from 0 through to 8 on my data set there, and you sort of go through crossing them off. We've got a 2, we've got a 5, we've got an 8, etc. So I'm going to sort of try and smash through this. 6 and another 4. Okay, so there's our dot plot. It's been placed on there for us. Okay, and so this looks nice and pretty, and so we can sort of think about this like we did before. The data is kind of shaped like this, and so we're going to expect that probably here's where we're going to find our averages. Okay, now we can actually use these dot plots to find the median, mode, and range of a data set. Okay, to do that, let's have a look at how we're going to find our range. So remember, range is the highest minus the lowest. Well, our highest value is 8, and lowest is 0. So 8 minus 0 is 8. Done. We can find the median as well. So there are 24 numbers in this data set, and so that means that it's going to be between 12 and 13. So let's count 12 values in. So we're going to count from the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13. 12 and 13 are both in this 3 column, so our median is going to be 3. Easy. Our mode, well, we just look for the one that has the highest number of them, which is column 4. It has the most number, so the mode of this data set is going to be 4. So if there's already been a graph created, it is very easy for us to find some of our measures of center. Okay, mean is a little bit more difficult to calculate from these, or not really done that way anyway. Okay, so let's have a look at our next one, which is a stem and leaf plot. Now this is an example of grouped data. Okay, on a stem and leaf plot, each little piece of data retains its value, which is very important. Now, we're going to have a look at this set of data, which is maybe a set of exam results, and not necessarily any of yours, but we're going to try and present it as a stem and leaf plot using an interval of 10. Okay, what that means is that each of these numbers can be brought down into their stem and their leaf. So let's take 88. Okay, we can turn 88 into the stem, which is 8, and the leaf part of it, I might choose a different number. Let's go 76. Okay, 88 doesn't really help, so we'll go with 76. So 76 becomes a stem of 7 and a leaf of 6. Okay, first part of the number, second part of the number. Now, if you've got more digits, it just sort of changes where you're going to break the stem from the leaf, etc. Okay, so we start in the 40s, so we don't need to go any lower than that, and we've got an interval of 10, which means we're going to have our 40s, let's choose a different color, our 40s, our 50s, 60, 70, 80, 90. So we've got 42. We just go to our 50s. We've got 54 and 57. 54, 57. Our 60s, 69, 65. So 65, 69, 70s. We've got 74, 76, 75. A couple of 76. So 74, 75, 5, and 76. 82, 3, 1, 2, 3, and 8. 81, 2, 3, and 88. And 91, 96. 91 and 96. Okay, and so there's our stem and leaf plot there, okay? And again, we can use that to find our medians and our modes. So median you would count through, find the middle value. Modes, well, it's sort of easy to see. We've got 7 and 5, 5, and there's our mode, okay? And our ranges from the lowest, 42, 96, okay? So it's quite easy to use our stem and leaf plots to find some of those different data measures of center as well. Okay, lastly, sometimes, now I know our textbook sort of tends to push this a little bit, but sometimes our outliers, well, there are these things called outliers, which are unusually large or unusually small values. Okay, so remember at the start I talked about the stones in the shoe, and maybe someone was with 200 stones in their shoe for some reason. That would be an outlier because it's an unusually large number of stones in that person's shoe. Okay, or they can be unusually small values depending upon what type of data we're talking about. Okay, now sometimes outliers can have an effect on the mean of a data set. Okay, so if we have a normal distribution, okay, we end up with a sort of data set that's nice and symmetrical like this. Okay, it's got like some values that are at the top, some values that are small, but the bulk of it's kind of in the middle, the normal kind of data you'd expect to get. Okay, so that's a normal type of distribution. Sometimes we can get something that's called a positive skew. Okay, positively skewed. Okay, that's when our data is bulked up down low, but then there's this long tail of stuff going off here. So there's a lot of these weird pieces of data that are very high, okay? And out here, you'd expect to find those outliers, those weird values that are up high. Now, what it can do is you're usually going to find that your median is at the peak of this sort of set of data. And with outliers out here, sometimes it can drag your mean higher, okay? So that can be the case sometimes with positively skewed data. So if we have then negatively skewed data, we get a sort of a piece of data set that kind of, when we graph it, it looks like this. There's a big bunch of stuff up high, and then we've got those weird lower values of outliers. Okay, and again, we tend to see the median at the bulk of the data here. And with these outliers that are quite low, what it tends to do is it tends to drag our mean lower because of those weird data that's sort of really down low. Okay, now it's very important for you to realize that it doesn't always happen, so you need to be careful with the way that you use it. Okay, but it is good for you to be able to start to talk about the shape of the data and whether or not there's particularly high values or particularly low values and what that might do to the data. Okay, sorry for the number of errors and bugs that are happening inside this video. My OneNote program has crashed a number of times during this recording, so hopefully it's making sense and the chop and changing isn't causing too much problems. Okay, thank you so much for watching. Bye.